Previously, we looked at the DDA algorithm and used it to cast a single ray in front of us. Now we'll use the algorithm to actually render our 3D scene. In order to render the screen, we'll cast a ray for each x coordinate on the screen, running from left to right. We can go to our map renderer, game renderer, and we can call that in its update function here. Okay, so that's set up, and the rest of the work will really be up above. The first question is, how do we find the ray's direction? The screen runs from left to right. This is called screen space, but these dimensions also have a meaning in a top-down view. We need to know how an x-coordinate on the screen corresponds to a direction in the world. From the diagram, we have that the A direction is the camera's forwards direction with its right direction subtracted. The B direction is just the camera's forwards direction, and then the C direction is the vector sum of the camera's forwards and right directions. So, in other words, we could say the world space direction vector is a linear combination of the camera's forwards and right vectors, where the coefficient used in that combination is determined by the x-coordinate of the screen. So let's go ahead and define a function which will give us the ray's direction. We can then use this in our raycast function. Okay, so the next bit to do is to cast the ray, and if we look down at the map renderer, we've got that mostly done. It's all of this stuff here. So we can grab all that code and then make a function up above. And I want this function to return both the distance and the tile object which was intersected. Okay, so far I've pretty much just adapted the code, removed any object-oriented stuff like self, whatever. They're all arguments. We just look along. Tile is tracking the current object that the ray is standing on. Every time we step forward, we are standing on a new object, so we go ahead and measure that, and then we break out of this when we're standing on something. Okay, so then we need to measure the distance. So the distance that the ray traveled before it hit something is, well, if the side variable is 0, then we've been stepping horizontally. Otherwise, okay, so what this side is doing is it's saying the most recent step, was that a horizontal or a vertical step? So then on the ray casting side, we've set up our ray. Go ahead and trace that out into the world. Just like that. And now we're We're getting so close. So what I'm going to do is we'll say each wall will be a vertical line, and with the vanishing, like perspective projection, that as we go further away from the wall, it'll be shrinking down into the center of the screen. So before I do anything, I'm going to just draw a solid wall for everything, which is just a fixed height. Okay, so height is the the screen height of the window, basically. So I'm going to get my top value and my bottom value. So we're grabbing the tile code, we're using the tile code to access into the palette, with the understanding that the first 4 elements of that are just junk numbers, temporary colors that we're using for other things. This top and bottom, we're offsetting from the center of the screen, which is half of the screen's height. We can just go ahead and draw a vertical line. Okay, so this may look a little strange, but we are selecting the appropriate color, I would say. Looks pretty good. So what we can do is we can achieve that perspective by taking this and dividing it by the distance, so that further wall segments are not as tall. And this is sort of working, but it's sort of messed up at the same time. LowDev's tutorial has a more rigorous explanation of why this is, but the basic idea, well, we could say it like this. I could say it like the ray has shot forward and it's hit something, but it hasn't shot forward. It's shot forward too far. So what I'm going to do, again, LowDev's tutorial has an excellent explanation of this, but I'm just going to go back to my trace function and I'm going to subtract the ray's step distance. And now everything is stable. That's very cool. And isn't it good that we did the work up front to get the camera sort of working properly, so we don't have to worry about like walking through walls or anything like that? Very cool. Okay, so I'm going to do a few things to soup this up. One thing, obviously, is we can go ahead and compile all of these functions. We can get that ngit decorator and put it everywhere. Yep, remembering that draw vertical line also needs to be compiled. In a previous video, I actually took that decorator off, but now it's back, and well, we've improved the performance. There are some other things we can do. One thing is all these walls are looking a little flat, right? So it doesn't matter, like, it's hard to see the, like, we can sort of see the perspective here, but it's a little bit off. So one thing I can do is we can go back to the color palette that we defined, and so here we've got colors 1 through 6, and I'm just going to make dark versions of this by halving the color values. And then we can go to the trace function, and we can use the fact that these first 6 colors are light and the next 6 colors are dark. So we've got that side variable, which will be 0 or 1. We can say if side is 1, tile, we'll just offset it by 6 to put it into the dark color region. Now this isn't perfect, because if we go, for instance, here, we can see that like both the vertical walls are dark. It's not perfect, but it is definitely better than nothing. And then another thing we can do is we've got a bit of redraw going on, because remember, before we rendered the scene, we filled in all these upper rectangle and the lower rectangle, but then these wall lines are coming along and drawing on top of that. So we can make the assumption that our world is closed, in the sense that every ray is going to hit something right? Otherwise we'd have gaps. We could walk off the edge of the earth or something. So we can make that assumption, and then we can assume that every ray that we're drawing is the closest ray that we're going to see. So we can draw a line vertically at the top region of the screen, then the wall, and then the floor below that. So in other words, we can go to our renderers update, and we can get rid of this rectangle stuff. And then in the raycast function, we can draw 2 more vertical lines. The ceiling, that will be from the top of the screen down to the top of the wall. And then I'll do the floor, and that will be from the bottom of the wall to the bottom of the screen. And there, I don't know how dramatic of a difference that is, but we definitely have reduced the overdraw. So instead of drawing over that ceiling and floor, we are drawing the ceiling and floor up to the wall segment for each vertical scan line across the screen. So yeah, there we have it. In the next section, we're going to be adding texture to these walls. I hope to see you there. All right, bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Carret, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.